So this problem says write out each sum. So this is the sum that we have here. And that just simply means write out each term. So when I plug in 0 here, that's going to be 2 times 0 plus 1. So that's going to be 1. Plus. Now the next one here is I'm going to plug in a 1. So when I go through these k, when they say k equaling 0 to n minus 1, that means I'm going to go 0, and then I'm going to go 1. So when k equals 1, that means it's going to be, I'm going to put a 1 in there. So that means it's going to be 2 times 1, which is 2, plus 1, which is 3. So that equals 3. And then I'm just going to keep running through the rest of these. And I don't know if you caught this or not, but if I know what this sequence is, which we should, we've dealt with it before, that means I'm just adding 2 every time. And this summation means I'm adding them together. So that means the next one will be plus 5, and then plus 7, and then plus ... and then we're going to go to n minus 1. So that means I'm going to say plus 2, and instead of k, I'm going to put n minus 1 there, because that's the last one, plus 1. So then I can simplify this, and I can simplify this to 1 plus 3 plus 5 plus 7 plus ... plus, oops. And now this 2n minus 1 plus 1 is, when I distribute here, that's going to be 2n minus 2 plus 1. It's going to be 2n minus 1. And that's going to be that's going to be writing out the sum right here. So that's the answer they're looking for this problem. So now let's take a look at this one. So this means I'm starting from k equals 2. And I'm dealing with the sequence -1 to the k times ln of k. And then I'm going to stop at n. Okay, so then for the first one is going to be k equals 2. So if k equals 2, that means I'm going to get for this -1 part, -1 squared, which is actually going to be a positive 1, and then times ln of 2. So since this is positive now, and that's times ln of 2, my answer for this is going to be ln of 2. So now I'm going to do k equals 3. And the reason I'm writing them out this way is because it looks a little intimidating when you look at the ln function. But it's really not. Watch what happens here. So this is going to be -1 to the third power, ln of 3. So -1 to the third power means I'm going to get a negative back. So it's going to be a -1 times ln of 3. So it's just going to be negative ln of 3. Or what I would write here is, instead of plus a -3, I'm going to write minus ln of 3. So then the process becomes a little easier once I see a few of those. Because then the next one then is going to be plus ln of 4 minus ln of 5. So then I'm going to write plus here, and then ... and then minus here. And it doesn't matter if you minus or plus this way. And this is going to turn out to be -1 to the n. Since I'm going to n, ln of n. So that's going to be writing out the sum. So you kind of see how that all works and plays together. Actually, this should be plus. So these are the two answers for these two problems. And I'll just circle them so you know what's expected.